Hello, and welcome to GLISA's walkthrough of the Climate Explorer. The Climate Explorer is an interactive tool that allows users to explore maps and graphs of county-level historical observations and future projections for different climate indicators, such as precipitation and temperature. It was developed by an interagency team of federal climate model experts and is managed by NOAA, the National Oceanic and Atmospheric Administration. This video is meant to provide additional guidance for potential end users in the Great Lakes region to help them navigate and better understand the Climate Explorer tool and its applications. After the introduction, we will explain how to use the tool, then walk through an example demonstration and interpret the tool's outputs. To begin, you will navigate to the homepage of the tool by searching for the Climate Explorer in your browser. It should be the first option that pops up. You can either click on one of the listed cities or type in your desired city or county. I'm going to briefly explain how to navigate and use the tool before moving into the more in-depth demonstration. You will see the various maps, graphs, and other outputs that you can interact with, which the tool labels as cards. You can either click on one of these cards from the home screen or click on the corresponding icons in the bottom navigation bar from anywhere in the tool. You can compare your county's past and projected precipitation, temperature, and other data spatially using the climate maps. You can view a time series of station data in your county using the climate graphs. You can view daily weather records and trends using the historical weather data. You can view how often the thresholds for different climate variables has been exceeded in your county using the historical thresholds. The tool also provides a time series of high tide flooding data and extra resources that may be relevant to your county for resilience planning. If you are using the tool for the first time, you may want to navigate to the tutorial version of the tool by clicking on the Frequently Asked Questions under the About Data drop-down. This provides a helpful on-screen walkthrough of the tool in addition to this video. Next, we will explore the tool more in depth using a Great Lakes city as an example. I will use Detroit, Michigan as the example here, which is located in Wayne County. You may use the climate maps to compare historical observations and future projections in your area. You can select the variable that you're interested in viewing by using the drop-down menu here, where you could select to view total precipitation, the number of days per year that receive over an inch of rain, or average daily maximum temperature. Each variable has a description that can be viewed by hovering over the question mark icon located on the left-hand side. The slider bar feature allows you to view historical observations on the left-hand side and future projected temperature on the right-hand side, to compare them directly and understand how different the future may look than the past. As we can see, on the left side of the graph, average daily maximum temperatures in the area were about 50 to 60 degrees Fahrenheit for the 1961 to 1990 period, and average maximum temperatures under the high emissions scenario are projected to be around 70 degrees. You may also compare two different projected future scenarios, one with lower emissions and one with higher emissions in the future. We can see the lower emissions scenario projects annual average temperatures around 60 to 70 degrees. The map will display future projections for 2090 by default, but this can be changed to a different year using the slider bar feature in the bottom right. All of these variables can be viewed at an annual or a seasonal scale. The climate graphs offer an alternative view of these observations and projections and how they have changed or will change over time. The default average maximum temperature graph shows high temperatures from the location you chose from 1950 to 2100. The dark gray bars indicate historical observations from weather stations, and the blue and red lines are average future projections for low and high emissions. The shaded bands show the range of values simulated by numerous global climate models. You can view the data on a monthly or an annual scale. You may navigate to the drop-down bar to select other data to view, such as temperature, precipitation, or other climate variables. You can hover over any part of the graph to display the specific values for that time period. Looking at days per year that exceed 90 degrees, in the 2050s, the higher emissions scenario projects an average of 47 days per year over 90 degrees, while the lower emission scenario projects an average of 37 days per year over 90 degrees. These can be compared to the 1961 to 1990 average of 9 days per year over 90 degrees. Or individual years, such as 16.2 days per year that was recorded in 1995. You can also download this data to view and use outside of the tool, either as an image of the chart displayed or CSV file of the underlying data. Any maps and charts in the Climate Explorer can also be downloaded as images. Using the historical weather data, you can zoom in and select the station that is closest to your community by clicking on the red dot using the map, or by using the drop-down menu to select the specific station that you're interested in. I am viewing the Dearborn station. Here we see a temperature graph on the left and precipitation graph on the right, with data from that station. On the left graph, the blue bars represent observed daily temperatures, and the green band shows the historical average temperature ranges from the 1981 to 2010 climate normal period. On the right graph, the blue area displays observed cumulative precipitation for individual years, and the black bar shows historical average cumulative precipitation. These charts are interactive, so you can zoom and drag to a specific date range that you want to see. You can compare how observed precipitation in your community has varied year to year. For example, here in Dearborn, it looks like there was a total annual precipitation of about 39 inches in 2014, which was higher than the normal year-to-date average of about 35 inches. While 2021 had an even higher observed total precipitation of about 50 inches, and 2022 had a lower observed total of about 27 inches of precipitation. When you navigate to the historical thresholds from the historical weather data, you'll be directed to the station that you were previously viewing. Again, I will be viewing the Dearborn station. The historical threshold graph displays how often the selected variable's threshold has been exceeded each year. You can change the variable data by using the drop-down menu, as well as the threshold range in inches and the threshold window in days. For example, you could look at the number of days that maximum temperature has surpassed 90 degrees. In 1999, it looks like there were 25 days recorded with a maximum temperature over 90 degrees, and 11 days in 2018. Or you could look at the number of times that precipitation has surpassed 3 inches in a 7-day period of time. We can see that there were 13 times in which this occurred in 1997, but none in 2011. There is also a high tide flooding tab, but this is only for tidal gauge stations in oceanic coastal locations, so this information does not apply to the Great Lakes region. Under the Take Action tab, the tool also points to some additional external resources to examine community vulnerability and climate concerns. The Climate Explorer is a useful tool to help users understand how location-specified climate conditions are projected to change compared to historical observations. I hope that this was a useful walkthrough and that this video helped you better understand how to use the Climate Explorer. This video was created by GLISA, a climate adaptation partnership team funded by the National Oceanic and Atmospheric Administration, dedicated to helping the Great Lakes region build lasting and equitable climate resilience. This is one of several tutorial videos intended to help make climate, weather, and coastal resilience tools more accessible to end users in the Great Lakes region, under a project funded by Michigan Sea Grant. There are also accompanying guidance documents available for each of the tools covered in these tutorial videos, available at this link, which is also in the video description. This video and accompanying guidance document were created for educational purposes only, and are in no way affiliated with the NOAA Climate Explorer or its developers.